arm. I think they just made it later and later until at least one of us is drunk enough that it either won't hurt or I can say it. Yeah, why don't you take it away?
So we're working on PTI. We do a lot of large web application infrastructure stuff. Most web apps these days are backed by databases. Something really interesting that Jared mentioned earlier was like instrumenting Oracle and DB2 and Sybase with dtrace is kind of difficult. You don't have any idea what the functions are. And dtrace is kind of a useless tool unless you can construct an articulate question. And when you don't know what any of the functions mean underneath the hood, you can't really create a good question. So Oracle comes with all these great tools itself, and so do other commercial databases. But the open source databases are really lacking. And the funny thing that we see is we have a whole bunch of Oracle DBAs, and one of them on staff is looking at a Postgres database, and they're like, oh yeah, I get it. It's a lot like Oracle. It's got procedural language, you know. Good, it has transactions, for God's sake. And they're looking at it, and then suddenly they're like, oh, it's a performance problem. So where are my X dollar tables? And you're like, you know, Oracle, you know, the Postgres goes, what the hell's an X dollar table? And the Oracle goes, you know, what am I supposed to do here? Like, how do I tell latch contention? How do I do, you know, understand basically on the database's perspective of what plogstack gives you, but on a much more granular level because it doesn't know about mutexes, it knows about various row level locks and table level locks and all that stuff. So this is kind of a preview of a presentation I've given in 2 weeks at PGCon East, and I'm going to skip over very fast. Postgres is awesome. It's got all sorts of cool features. Postgres is really lacking. If you've used a commercial database and you start to switch to an open source database, it's simple questions like, how do I back up my database? How do I see what it's doing? And people are like, I mean, your app's running, so it's got to be working. So, I mean, and people, like you show, I don't know, it's really funny. Wes Furlong, who works for us, wrote the PHP dtrace use provider. He went to a Microsoft conference, and he ran strace on a projector, and the Microsoft guy pulled a Brian. He like jumped up, and was like, holy shit, what is that? And he's like, it's strace. It shows. He's like, we need that.
Having run strace on Windows, and being one of the few people who would say this, the reason strace is useless on Windows is because they're serious about their little object model. Right? So every call is create object, wait on object, foo from object with opaque handle types, right? It's not like when the strace output on units where actually means things.
Yeah. So it was interesting to see them that excited about something that's that old, which is, you know. So you know, you show a Postgres, you know, DBA strace, and they think, oh my God, this is awesome. But really, that doesn't really tell you much. It tells you why something's like gratuitously broken, but it doesn't really give you any tools. So most of this talks about ZFS and how I still am employed because of ZFS. They had a catastrophic failure, lost like all the data, and then we decided it was good from the morning, and we were like, ZFS rollback. And it was like from 6 a.m. that morning, it took like 3 or 4 seconds. And we started the database back up, and we're like, that's good. and like, it was a 1.8 terabyte database, so it was, yeah. So dynamic tracing, what does that give you? One, it kind of attempts to give you, in a bad way, the best way possible, instrumentation like Oracle has on what the hell is going on in the system, right? You can see disk accesses, you can see page faults, you can see all of that stuff, and you can also see all the way up into the app. So, in Postgres, just like anything else, you can plan a query. Like you run a query, and it takes 15 minutes. You can type explain, and it tells you, hey, this is how I'm going to go about solving this problem. And then you type explain analyze, and it actually solves the problem and tells you how off it was from its conjecture, mainly related to costs. But a lot of times you just don't understand why something's slow. And that comes back to a kind of a concept that database administrators just can't cope with. It's like, yeah, there could be 2 queries running at the same time in the system. They're like, whoa, like I have this plan. This is my plan. Like, yeah, there's 85 other plans executing at the same time. And guess what? They're using the same spindles you're using, and you have to wait in line. And And being able to show them that is much cooler. So you can write things. This isn't the stable API for the Postgres provider. This is the one we hacked so we can see it system-wide. But this basically comes into the, every time Postgres process runs a query, it goes and tells somebody, hey, I'm about to run this query. So we instrument that point, and we can pull that in and look at I/O starts and figure out exactly what we plan on going and doing. So when we run this thing, you can see someone else running a query, right? I'm going to select that, and I read off the SD1 16K. I ran this other query, and I read off SD2, much larger than 71 megs of data. So you can actually watch things happening in your system. And a much cooler tool than that is called PG file stress, which takes all that information about the reads and the writes that you're doing, maps it back to the file descriptor, finds it on the file system, goes and looks it up in Postgres to turn it back into a tuple relation, and then tells you what table space, what schema, and what table or index is actually getting the read or the write, which is the number of them, min, max, average, could have standard D.
So that's using dtrace, the dtrace provider as a backend?
That uses the, this actually doesn't use the Postgres provider at all. It just uses normal dtrace providers. Yes,
Cool.
it does. So that's it. So now actually do something. So on a production system.
Are you on a production system?
Yes.
Sweet.
Is there like a special
There's
T-shirt
no
for
other
that?
place.
There is. Should be.
So I don't know what's doing right now, but yeah.
On the pause. Please be pickable. Please be pickable. Please be pickable.
Instrumenting, dot, dot, dot. Yeah. So
Never let Brian on
you
ice
can see
config.
table spaces, and I think the important part of this is too many table spaces to get access. So this one is, I don't know. Let's see.
So Theo, what is that actually? You said it's so the data that's pulling out of the script.
So the script here is a PostScript. And it actually has help. All right, so what it does is it's a little dtrace provider, it's like that, which actually is not checking the I/O start probes. It's actually doing reads and writes. So it's doing not what it's touching. It's not what's touching disk. It's what you intend to read and write. Most of it's in hopefully a file buffer cache. But so yeah, it's matching Postgres processes, looking for reads and writes, and accumulating them, doing average, average, min, and max, and counts. And then it prints them out, and then consumes it itself. It's really fugly. And then
It's actually making a query to the database.
every time it sees a new relation in here, so it reads the output right here. It reads our dtrace output, and then pulls in the attributes, and if it doesn't have a map, it goes and creates a map. There's a map to PG function which caches. It just looks up the file path on disk, tries to find it in the database, and it'll pull it back. So one of the problems that we have with that, which is actually a big complaint of Postgres, and MySQL doesn't suffer from these problems because the C in ACID for MySQL is like a lowercase c. So if you see this go in a second,
I asked was actually pretty inconsistent. And that was the
yeah. So consistency is all relative. I'm like, it's consistent to me. So we do a lot of large jobs where temp tables are used, or I'm going to do an insert into, see those PG colon, PG colon, PG colon, PG colon? Those are relations that I cannot see into the transaction of. Someone's doing something and those tables haven't been committed yet, the DDL hasn't been committed yet, so my guy who wants to look them up is like, what's that? And they're like, oh, it doesn't exist. So it's consistent for that guy. It'd be really nice to be able to, be like, what will it be? Because usually when you do really large operations like, I want to materialize a view of something that's 30 million rows, it's going to go write 500 megs of data out to disk, and it's all PG colon 25, 37 until it's done, and then you kind of have to look it up and figure it out where it was. So this is a production database.
Can I ask why it's sub-lotto, poker, blackjack? What's
It's a online lottery service.
Is it right?
Yeah, cool.
Whoa.
So yeah, 30,000 block requests for that. Those are number of reads and writes, not the bytes. So they do decent amount of traffic.
So if you're a person who programs and works on the system, how sensible is this output? To me, it's kind of like line noise, and it's not a criticism.
So for a database administrator, they know what all these tables are for one, and the all data one, slow data one. This is the system we're moving from. This is the one. Look at this is the one that had the wonderful recovery. As you can see, the ZFS lists stuff for things like the system is dying a very slow and painful death. We have one processor offline and like 45,000 FNADM alerts in it. It's pretty cool. Maybe ZFS lists it. There we go. So yeah, PG data, fucked again. There you go. That's great. Works, 2008. So we had write-ahead log corruption, and you'd start up Postgres and it would just die. So ZFS enabled us to do trial and error response to that. So it was rollback, startup, that doesn't work. Okay, hack the Postgres source, rollback, startup, that doesn't work. Hack the source, and you can't restore 1.8 terabytes like that, but you can roll back to it. So it was pretty good. It took about 4 hours to get the instance up from catastrophic data corruption, as opposed to like a week, which was pretty good.
You want me asking, was that application-induced corruption? Was that device-induced corruption?
Given that we're one processor down, I think it was hardware failure. It was memory corruption. Because ZFS didn't throw any checks and errors. So, not that that's, have my own ZFS war stories. Don't ever snapshot something with 2 ats in the name. Bad stuff happens. All the ZFS tools set fault, then you can't boot. Did that on a production system too, during a demo. It was like, oh look, snapshot, and I typed those, and it said, like something like data sample at my snapshot, and then I was like, ZFS list, set fault. ZFS export, set fault. It was everything, and then reboot was bad.
There's something.
Is that fixed now?
I don't know.
It's fixed in Open Solaris. I don't know. I think it's an update 4. It wasn't an update 3. That's where I had some fun. So this one is the same box, same database. I don't know if they've successfully migrated stuff off of it, but.
Would it be reasonable to get some of this information out of a stable provider, or does the stable Postgres provider provide any of this information that you need in terms of what you need?
So the stable Postgres provider doesn't provide anything that I need.
Okay.
It provides really things for the database developers to try to handle horizontal scalability problems on the box. So like when I put a Postgres instance on 16 CPUs, why is it slow? Where's the lock convention? Being able to do that. So it has a lot of things. Like you can look at the provider. So this one's a lot busier, and it has a lot more disks in it. This one has like.
I think one of the things that we have to do is convince the community to allow probes that are not just for developers to be integrated into the Postgres provider. And I'll talk with this.
Excellent. Thank you, Robert.
Yeah, so this one has 40, 20, 80, 14, 14, 28, 108 spindles on that box. So that one's big. And old and slow, and the new one has 14 spindles and is faster. So the question was, how do you use this information? And the way you use this information is the DBA goes, oh my God, we're writing to CCT log who and CCT log SLRF. Those things have nothing to do with each other. It's not the same guy writing to them. So I can either move them onto different disks or just make them not run at the same time. So this one is it's an operational data store. It runs like 14-hour-long queries. And it's amazing. It's that whole, thrashing problem, right? I can run a 1-minute query and a 1-minute query. And if I go against the same disk, I can run at the same time, and they'll take 40 minutes, which is bad. So this allows people to analyze, like, why, you can put the DBAs, like, who's touching this table? And it's them, of course. And so what you can do on this, I think I have so this is some of the tables on that. So without the stable provider, without a hack to the provider, I do something like, wait, they can see connection link to there from yes. Okay, so that runs. Okay, got a million rows in that table. That's not MySQL. That's not accessing the size counter. That's actually doing full table scan. So I can go look at this and say, hey, look, someone just ran that query, and it did 131,000 bytes off of SD4 and read, and it just flips it out. And then at the bottom, that's what I intended to read. So all my good queries have no SD lines and a read line, which is like, I went and called the read system call and read like a gig of information, and I didn't touch your disks at all. So this is bad. Obviously, it's from 2003. Nobody's looking at that data right now. So we should be able to see that if I do like a select. So we can come back to that. So we've hacked the provider up a bit, mainly because the original entrance of the providers were doing scalability testing. So we added a provider called PG report activity statement start. So basically, every time a statement starts in the system, it has a dtrace probe with one argument, which is the string, and you can just copy unstring, and everything works. I just wrote this script, and it stops from unresponsiveness. So I should see all the queries that run in the system. So anything, this is a developed system, but anytime I run a query in here. There you go, awesome.
Something minus W on there quite yet.
What's that?
I assume you're presumably not boarding because of the nature of the handling. That means it wasn't able to run before the second.
Yeah, I don't know.
What, you run out of 3 or 4?
This box is updated for. That should be pretty.
TSC, just fix it.
It's just the issue.
I thought that was fixing up too. No, because it's still P-patch. That's gotta be TSC.
Okay, so that's not good. Here we go. Let's change this.
It's boarding too fast. It's boarding faster.
So that's the select. I just read that. I hope that if I run this again, I didn't even get read, so it's in the buffer cache, so Postgres buffer cache, which is really good. So you can do all sorts of useful things in here. The biggest problem that we have with this is that, so it's pretty easy to track the process down to which disk it is reading from to pull the data in, because if I need the data, then it goes and gets it. But when it changes data, it changes it in memory, and that gets written out in the background because it's not using ODirect. And then it's like, I have no idea which query did it. So you have to be creative and wrong in trying to assess that. It'd be really cool if there was a way to figure out exactly if a page was flushed to disk, which process it came from.
Can you modify Postgres to do that tagging? Or is that?
To do what?
Is it possible to tag when the transaction starts or the?
When a transaction starts, sure, but not when it's hard to tag when you when you dirty a page.
Right.
So I could say dirtying a page with the query name and probably just say dirtying a page and you type back your PID. So, and all this stuff works pretty well on MySQL. And it's actually easier on MySQL because it's one process and it's threaded. So you can track that stuff a little bit easier. You don't even have to have a PID provider because when you attach to the process, you can kind of really dig in and still see everything that's going on because it's multiple processes, multiple threads. So that's it.
Cool, thanks guys.